The broadcast is now starting. All attendees are in listen-only mode.
Hello friends. Very good morning and very good evening. How is everybody doing? Uh, so yesterday was Ganesh Chaturthi in India. I'm sure most of you have celebrated Ganesha festival. Okay. So happy Ganesha Chaturthi, friends. So may God bless everybody with health, wealth, knowledge and prosperity. Yeah, thanks friends. You know, we did celebrate yesterday. So we'll get started with today's discussion. One of our friend is asking, where are you located? Yes, I'm based out of Bangalore, friends. Thanks, Ashutosh. So good morning, Amarnath, Anand, Ashutosh, Jyoti, Nishit, Radhakant, Urvi, Vignesh, Vivek. Okay. Let's quickly do a recap of what we learned. You know, there are a couple of questions in the coming slides. You know, please answer them, and then we'll get started with today's discussion, friends. Topic for today. Today we'll do a quick revision, and we'll look at the code for combiner and partitioner, and then we will see the different ways of doing joins, and we'll look at the Hadoop data types, and we'll understand how to create custom data types, and we'll also look at the input formats and output formats that are part of Hadoop, and we'll look at sequence files. We'll understand what are sequence files, when to use sequence files, and we'll understand the feature of distributed cache and MR unit. This is very important from the testing point of view, from the unit testing point of view. Whenever you develop a program, you don't have to build your jar and take it to the cluster and test your code. I mean, you can test it well before you test it on the cluster. So for that, you can use the MR unit testing framework, and we will also understand the other Hadoop advanced features, Hadoop counters. Today's session, we will be talking about the advanced features. Let's get started with pre-class questions. So these questions focus on reviewing what we learned in the last class. For the ones who joined late, very good morning and very good evening, friends. So most importantly, so we understood the MapReduce model, right? Within the MapReduce model, we understood how Hadoop makes use of the MapReduce model, right? We understood what are the phases within the MapReduce model, right? So we understood that there are four phases, right? The split phase, the map phase, the shuffle phase, and the reduce phase. Okay. And input data will be whenever we feed the input data, that input data will be converted into a number of will be splits, and each split will be assigned to a mapper, and the mapper performs the data processing on the split assigned to it, and then it outputs intermediate output. This intermediate output will not be on HDFS, it will be on the local drive of which the mapper task runs, and this output is then copied. It is then copied to the reducer node, right? And this phase is called as a shuffle. And once after the data is copied to the reduce node, the sorting of the data, then the grouping of the data happens, and the output of the grouping will be the input for the reduce phase. Okay, in the reduce phase, aggregation happens, and output is returned into HDFS. So these are the different phases in MapReduce. Okay. Now let's answer a couple of questions. Can you use the MapReduce algorithm to perform a relational join on two large tables sharing a key? Assume that the two tables are formatted as comma separated files. Can you all attempt, please? Okay, I'm seeing mixed okay, answers, but everybody attempt. Just think how it can be done, because you have to deal with deal in terms of keys and value pair. Right. Some of you are saying yes, some of you are saying no. The answer is yes. We can do the joins. So that's what we will understand today. Today we'll understand what are the different techniques that we can use in MapReduce in order to do the joins. Okay. We'll understand what is map side join, what is the reduce side join. What types of algorithms are difficult to express in MapReduce? What type of algorithms are difficult to express in MapReduce? I request everybody to attempt this question, friends. Amarnath, Amit, Ashutosh, Chandan, Jyoti, Nishita, Nishit, Radhakant, Raji, Urvi. Just think about it. What are the principles that we understood about the MapReduce? The MapReduce, it is a programming model which allows us to process data parallelly, right? So using this model, whenever you use this model, the mappers which run parallelly, they run in isolation. They do not interact with one another, and they do not share state with each other, right? So the answer is the first one. The algorithms that require a global and shared state, this we cannot express in MapReduce. Let me, you can see here, MapReduce paradigm works in a massively parallel system. Map and reduce tasks execute in isolation. So algorithms which require a global shared state to be maintained are not suitable for MapReduce framework. Let me give you one example. Please tell me if it is possible. Assume you have billions of rows, right? Billions of rows, and each row has some key, right? Some primary key, and assume that the records are sorted by the primary key. Okay. Now, can we write a MapReduce program and find out whether the data inside that file is sorted or not? Can you do that? Can we write a MapReduce program to check if the data is sorted? Just think about it. The people who are saying yes, just think how it can be done. If it is possible, please write the algorithm and send it across to me. Okay. The answer is no, we cannot. Because the moment you split your data into multiple splits, multiple chunks, right? You need a reference. You need to know with respect to the data that you have, the other part, is it sorted or not? So hence, it is not possible to express those kind of algorithms in MapReduce. Okay. People who are saying yes, you can attempt. You can try writing a MapReduce program for that. Okay. So Radhakant, Amit, yeah, your answer is correct. It is no, we cannot express those kind of algorithms. At what stage in the MapReduce tasks execution a reduce function starts? Recollect the different phases. Recollect the different phases in the MapReduce and please answer this question. Good evening, Abhijit. Okay, in order to answer this question, friends, recollect the word count program, right? The analogy that I gave. Okay, or the one we solved in the class, the word count. Okay, so what you understood, friends? I mean, if I want to know, let me show that. Okay, let me show that class 3 example that we worked on, right? So this was the example that we took in the last class, right? Let's look at the mapper output here. So this was the mapper output 1, okay, and this is the mapper output 2. In order to do the reduce, for example, you can see this, the word bear, it is in the mapper output 1 and the mapper output 3. So can I calculate the occurrence of word bear with just the mapper output 1? Can I? Radhakant, Ashutosh, please answer. Can I count the occurrence of the word bear 1 with just the mapper output 1? No, it is not possible, right? We cannot apply the reduce function till all the map tasks are completed. Okay, so now please answer. What is the correct answer? Answer is 3. After processing for all the map task is completed, then only we can do that, right? Then only we can start the reduce function. The reduce task works on the output of the map task, and the output from all the mappers is required to start the reduce process. Now another question. You want to reduce the traffic between mapper and reducer. Traffic means the amount of data that you send across from the mapper to the reducer. So your class should implement which interface, friends? Combiner. That's correct. In the last class we understood. We use combiner for that. Combiner means it does a local reduce operation. It acts as a mini reducer. It works on the mapper output. It will runs on the node on which the mapper runs. Okay. It's also called as a mini reducer. It's also called as a semi reducer. It is also called as local reducer. So combiners, they are basically mini reducers. They essentially lessen the workload which is passed on to further reducers. Here amount of traffic means data. It's a data. Basically what is on the network, right? When you talk in the computer networks, the traffic means it's the amount of data that is transferred, Vivek. Now coming to, there is one more question I have for you, friends. Can you all quickly write the MapReduce programming model? What does in this format? Okay, here is the format. Tell me what your mapper input takes and what is your mapper output, and what your reducer input and what is the reducer output. Can you quickly type the model? We'll proceed further. I just want to make sure that you are able to recollect. Or let's do this way. What is the mapper input? Is it a list of, okay, let's do this way. So mapper input. Is it a key value or a list of key value pair? Mapper input, is it key value or list of key value pair? It's a key value. What is the mapper output? Is it key value or list of key value pair? Mapper output, what is mapper output? Is it key value or list of key value pair? It's a list of key value pair, right? And what is the reducer input? What is reducer input? Is it key value, or is it list of key value, or key and list of values? It's a key and list of values. What is it? No, Amit, it is not the output of mapper, is not the input to your reducer. No, 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 no. There is input in some phases. Please recollect. After the mapper output is taken by the shuffle phase. Shuffle phase, what it does? It takes the records, right, and decides which reducer it should receive and sends that record. Basically, record contains key value pair to the reducer. On the reducer, when the data is received, right, what does it do? It sorts the data and then it groups the data by key. So the input to reducer is key and list of values. So what is our reducer output? List of key values, right, friends? So this is you should never forget this model. Okay, even if someone wakes you up in your dream, right? If you are sleeping, then you should be able to state this model correctly, because this is the core of MapReduce, right? This is the core of data processing. You have to think in terms of keys and values. Okay, so now another question, friends, here. Can you order them in the right sequence? We'll then quickly get started. Can you order them in the right sequence here, the different phases? Now send the answer. Please send me answer in the one line, like split, reduce, shuffle, map. Okay. Please send me the answer in a single line. Okay, Raji has answered correct. Raji, please think about it. There is one shuffle and combine. You need to make correction. Same with Anand. When does combine run? Please, Anand. Amarnath, you are right. Okay. The answer is first is split. Okay. Next map. Right, and the mapper node, what did we say? Combiner runs on the mapper output, and then shuffle starts, and then reduce. Okay. So this is the correct answer. Any questions? Shall we proceed? Shall we look at the combiner and how to write a combiner and reducer now? Is it clear, friends? Okay. So let's understand how to write a combiner. So these are the two topics that we learned in the last class, right? Combiners, we understood that. We use that to reduce the amount of data that gets sent from mapper to the reducer. So we want to reduce the network I/O. So what we do a local reduce. Local reduce, we also understood we can run combiners only if it satisfies those mathematical properties, right? Associative property and commutative property. For that, I gave an examples for sum and average. Okay. So now what we will do, we'll see how we can write the code for that. So in the last class, did we see the code? I don't think so. We just understood the concept, right? Did we see the code for the combiner, friends? No. Yeah, we just only understood the concept. Yes. Now let's look at the code. The code is very simple. As I mentioned in the last class, right? In the last class, I mentioned that whenever you want to implement a combiner, all you need to do is, just it's as simple as setting the no problem. It is as simple as setting the reducer class as your combiner class in your driver. Okay, in your driver class, you do the required configuration in order to set the combiner. Let's look at it. Let's look at this program. This is a example for combiners. Basically, to illustrate the working of combiner, written this program. Okay, this is a word count program. Okay. So any MapReduce program we have understood, it consists of 3 classes. One is the driver class, second mapper class, third reducer class. So what we have here, this is the driver class. So in the driver class, mostly it contains job configuration. So let's go to our driver class. So driver class will have the job configuration. Here you can see, so job configuration has created the instance of job configuration, and we have set the job name, we have set the output key, output value, data types, and then here is our map class. And this map class is same as the, okay, it is same as the class that we wrote previously. Okay. And so here is how you set the combiner. Okay, so combiner, how do you do? Using your job configuration, right? Using your job configuration API, you call the method set combiner class, and you can set your reducer class itself. Okay. You can set your reducer class, and so this is one way of creating your combiner. I mean, if you want to have a different logic for the local MapReduce operation, then also you can do that. Okay. Then that also you can do. Only thing you need to make sure is, if you develop your own combiner, the input, right? The input key and value data type should be same as your reducer input key and value data type. Okay. So here, since it's a word count, right, we can do the local aggregation by using the same logic that we wrote for the reducer. So here we are setting the reduce class itself. Okay. So this is the only line of change you have to make. Okay. If your combiner logic, the local reduce logic is same as the reducer logic, then you can set the reducer class itself. So this is the only line of change. One second. Now, now we will see the difference between the word count program that we wrote earlier and this when we execute, right? After execution, we look at the job summary, and we will see the difference between the earlier MapReduce program and this MapReduce program. Okay, so it expects the input in. So this is a word called combiner example, right? Hadoop. The way we execute our program is we use the Hadoop jar option, and then we specify our jar file, and then we put our driver class. This is the HDFS input location, and this is the HDFS output location. So the data input location is user Cloudera class 3 WC input. So let's look at it. User Cloudera. Okay. Oh, we don't have it. So let's create this. Let's create the directory. So we are trying to add the data for word count program. So we are using the file system client to add the data into our Hadoop cluster. So using the file system client, we are using the put option. Okay, put option we use to copy the file from local file system into HDFS. So we can copy multiple files by specifying this this operator. Okay. Now let's look at class this folder now. We should be able to see. Yeah, we are able to see the class 3. So you can see. So it has the 2 data files. Okay. Now what we will do? Now we'll run the combiner example. Okay. Now we'll run the combiner example. In the combiner example, I repeat the command again. We always use Hadoop jar option, right? This is Hadoop is a client, and jar is the option that we use to execute our MapReduce program. Okay. And this is our jar name, right? We have exported this as a jar. Okay, I've exported this as a jar, and I have moved that jar here. I moved that jar to VM, okay, and this is my driver class, and this is our input folder, HDFS folder, and this is the output folder. So let's execute. So we are interested, see the output view of this program, the actual data that is returned to HDFS, it will be same as the previous the word count program. But the difference will be in the job summary. We will see that that there will be some combine phase will be enabled, and there will be some input to the combiner phase. Okay. So let's check that. Okay. So we'll execute the. You can see this. This is this job got submitted to our cluster. Okay. Good morning, Gaurav. Good evening. Yeah, welcome to session number 4. No problem. Please please watch the recording okay, and recap for the recapping the class 1 topics. And also we have started the discussion today understanding the combiner concepts, Gaurav. Okay, we just looked at the code. I mean, how to develop a combiner. It is just, you have to make if you are using the reducer code, reducer logic for your combiner, I mean, all you need to do is just to make one single line of change. Okay. In your driver class, you need to call using the job configuration API. You set your combiner class by calling set combiner class, and here you can set pass your reduce class itself. Okay. And after doing that, so what we did, we just saw the execution of that program, Gaurav. Now here, so please pay attention, friends. This is what we are interested in. You remember in the class number 2, I did mention that in the job summary, right? In the job summary, it gives the amount of data that is written, right? This is all about the amount of data, the files, the size of the data that's written into files, and also the size of the data that is written into HDFS. And it also gives us the number of records, right, that gets passed between these phases. Remember these phases. Okay. So now let's look at that. So since we are saying there is a map, output of map is our input of combine, output of combine is input for shuffle, output of shuffle is input for reduce. So let's look at all these numbers. Okay. First, let's look at a map output. Okay. Records. So we are interested in records. So mapper output records, you can see it is 1515. Okay. So this mapper output will be input for combine. So let's look at the input for combine. You can see 1515. Okay. Then the output of, let's look at the output of combine. Combine output, you can see this is the combine output. So numbers have reduced from, the records have been reduced from 1515 to 863. Okay. So 863, so this will be the input for the shuffle. Okay. So in the job summary, it calls it as reduce only. Okay, do not get confused. You can see this combine input record, combine output records 863 has become input for your shuffle. Okay. So in the job summary, it says as reduce. So reduce input records, you can see 863. Now this is the reduce output records will be there, 794. Okay. So this is your shuffle output. Okay. So this is your shuffle output. And this is the actual reduce input. You can see here reduce input groups. So this is the actual input for your reduce, okay, for the reduce method. So this is the actual input. You can see 794, and you can see the reduce output. So 794. So what we are interested, so we see that there is the combine phase here. Combine the output of mapper. The output of mapper was fed to the combiner, right? And combiner did the local reduce and it outputted 863 records. The input it took was 1515. Is this clear, friends? Amarnath, Vignesh, is it clear? Okay, great. So now are you able to read this job summary, friends? Is it making sense now? This job summary, what all the information is printed here? Now let's move on. Radhakant says it is not in sequence. I mean it is printed at the end, Radhakant. So yes, definitely it is not in. They have not put it in the right order. Yeah, I mean we can open a bug for this and they'll fix it. One thing we can do is we can open a bug with Apache. They'll fix this. Can we write our own combiner class? Yes, Ashutosh, you can write. Okay. The only criteria you need to take care is the input data types, right? The input key and input value types should be same as your reducer input key and reducer output key. Okay. Sorry, reducer input key and reducer input value. Now let's look at the partitioner concepts. So what we understood in the last class about the partitioners, we use partitioners. If you want to, please answer this question. A, reduce the traffic, right, in the network whenever data is sent from mapper to the reducer. Option B, control the distribution of records to reducers, or control the distribution of load across reducers. What do we use for? What do we use partitioners for? Okay, it's mostly for it's a uniform distribution of the load, right? And the partitioner, so they are inherently responsible for deciding to which reducer the record needs to go. Okay, you can see each determines which reducer is responsible for a particular key, but the actual use is for the uniform distribution. Now let's look at an example here. Let's see how we can control the partitioning of the data. Okay. Now before we move on, can you help me with this? What are the 3 subphases in shuffle? Can you recollect and answer? What are the 3 subphases in shuffle? Amarnath, Anand, Ashutosh, Chandan, Gaurav, Jyoti, Nishit, Radhakant, Raji, Urvi, Vivek, Vignesh. Can you answer? What is the first one? Okay, our friend Vivek is saying it's a partition. That is correct. What's the next phase? Sorting, right, and grouping. Okay. So these are the 3 phases. So now we are looking at this. partition. Within the partition, what happens? Within the partition, we decide, right, which record needs to, the framework decides the output of mapper, the output of the mapper, right, to which reducer it has to go. All that is decided in the partition phase. Okay. Now let's see how we can control this. The examples that we will be seeing now. So what it does is, for the word count MapReduce program, right? So we will use 3 reducers, right? In the earlier we used only 1 reducer. We'll use 3 reducers. Okay, 1 reducer for doing the aggregation for the words starting with alphabets. Okay, and 1 reducer for the words starting with numerical, and 1 reducer for the words starting with special characters or any words that start with other than numerical and alphabet. So let's see if how to implement such kind of partitioner. Okay, here always. So quick question: our typical MapReduce program, right? What all classes does it contain? The basic classes. If you want to run your MapReduce program, right? What are the classes you write? It's a driver, mapper, and reducer. Okay, driver, mapper, and reducer. Jyoti, any questions? Jyoti, is it clear? It's a driver. See, this is the driver. This is the first class, so you can write them separately also. You can see here in one of the cases I've written them separately. You can see this is a word count I've written. So I've written the driver separately. You can see this has only the driver code, right? And here you have the mapper, and here you have the reducer. Okay, these are the minimum classes that you write for your MapReduce program. Now let's look at the combiner partitioner. So for the use case that I just described, let's see. First, let's look at the starting point of our execution is our driver class main method. Let's go to driver class main method. Here you can see we have created an instance of job configuration, right? Which is part of the package Arg Apache Hadoop MapRed, and in that, we are setting the job name. The first thing, okay. When we write our own partitioner, right, number of reducers should be A, only 1, B, more than 1. When we write our own partitioner, then number of reducers should be A, only 1, B, more than 1. It's a more than 1. If it is 1, do we need a partitioner? No, we don't need, right? Everything will go to the same reducer. We don't need. Amarnath, is it clear, Amarnath? If it is only 1, then there is no partitioning logic at all. It just goes to everything goes to one reducer. Okay, so partitioner comes into picture when you have more than one reducer. So here, we are setting it to 3, and we are setting the mapper class. This is the same class that we wrote in the previous class. Okay, and here we are enabling the combiner optionally. Okay, and this is the reducer class. We are setting the reducer class, and this is what we are interested in. Use the custom partitioner. How do we use the custom partitioner? We enable the custom partitioner by calling set partitioner class, right, in the job configuration API. So we call the set partitioner class, and we pass our partitioner class. So let's look at our partitioner. Okay. So this is our partitioner class. It implements partitioner interface, and here this 2 data types, right? So these 2 data types are the mapper output key and the mapper output value. Okay. So this is the mapper output key and the mapper output value. And when we implement the partition interface, we have to override a method called getPartition. Okay, so we override a method called getPartition. So in this getPartition, you can see it takes 3 parameters. This is the key, this is a mapper output key, value, mapper output value, and the number of partition. This is the number of partitions is equal to the number what we specified here. Set number of reduced tasks. We mentioned 3, so that gets passed here. And here what we are doing, so we want to send our words to 3 different reducers, right, based on the first letter in that word. So you can see we are first getting the key, right, and we are getting the first character in that key. Key is basically word. Now if the first character is if the first character is an alphabet and it starts with an alphabet A or Z, between A and Z, and we return 0. 0 means so this is an index of the first reducer. 0 is the index of first reducer. If I have 3 reducers, the indexes will be 0, 1, 2. Okay. So return 0 means this record should be sent to first reducer. And then if the first character is a numerical, if it is a numerical, send the record to second reducer. Else all the other records, right, all other records whose word start with a special character, send it to third reducer. So this is the way we write our partitioner. Okay. So quick question here, right? Maybe I'll ask that after we see the demo. Is this part clear? Shall we see the execution? Okay, let's see the execution. This is a partitioner example, right? Okay, here you can see again we use a Hadoop client, right, jar option, and this is our jar file which contains our all MapReduce programs, right, for the class that are in this project, class 3, and this is our driver class, word count with partitioner, and this is our input directory, and this is output directory. Okay. So now let's just run this program. So our program, whatever we submitted, right, it is running on the cluster. So now the map phase is completed. Reduce phase is in progress. Raji asked, by default there will be only one reducer. Yes, Raji, you are correct. By default there will be one reducer. Now let's look at the output. Where did it write? It's class 3 WC partition output 1. Okay, class 3 W3 partition 1. Okay. Now you can see 3 partition files created. Sorry, 3 parts are created. One file was emitted by one reducer. If I have 3 reducers, how many files will be emitted? 3. If I have 4, there will be 4 reducers. Each file is output of our one reducer. Okay. Let's open this and see. You can see this. This was the first reducer, right? We asked it to take care of the words starting with alphabets. You can see it has all the words which start with alphabets. And then let's look at the second. It contains the occurrence of the words which start with numerical. Okay, you can see this. It's all the words are starting with some numerical. The third file, right? It contains the words starting with special characters. You can see dollar, double quote, right? So all special characters. So this is how you can control the distribution of load across reducers. using the partition logic. Now, quick question, right? So when you write your own partitioner, right, which is the method you implement? Okay, which is the method you implement? Question A, hash partitioner. Which is the interface that you implement? Sorry, which is the interface that you implement? Hash partitioner. Okay, which is the interface that you implement? It's a partitioner interface, right? You can see here we implemented the partitioner interface. Okay. Now, our next question. Okay. So next question is, when you implement your partitioner, right? So which is the method you implement, right? You provide the implementation. One, get reducer number. B, okay, get partition. Okay, you can see. So which is the method? Okay, these two things you need to remember. One is the partitioner interface, and this is the method you implement. Get partition, not get reducer number. No, Vivek, look at it. So that was a trap. Get reducer number, right? It feels so close. No problem. So it's a get partition. So this is the class and this is the method. With that, we end our discussion on partitioners and combiners. Now we'll take a look at the different join techniques that we need to understand. So in the joins, so first of all, we all agree that joins can be done. Right? First, we all understand we can do the joins. So what Hadoop provides? Hadoop provides two techniques for join. Okay, before we get on to the understanding those techniques, is everybody from RDBMS background? Has everyone written SQL queries? Amarnath, Amit, Anand, Ashutosh, Chandan, Gaurav, Jyoti, Nishit. Okay, great. So you have written all join queries. Okay, great. So now, for the ones who have not really done. Okay, sorry friends. We do joins, right, when we have two data sets, and just having a data set is not enough, right? If I have so what we need to have? We need to have some relation. So that relation is established by keys, right? The common keys. So we need to have some relation, right, between the two data sets, and that relation is established by the common keys in these two data sets. Now let me give you an example of employee data. Employee data, what will have? Employee ID, name, department ID, right? And let's say we have another table called department. And the department, we have department ID, department name. Now here in these two data sets, can you tell me what is the relation, which key establishes the relation between those two data sets? So it is very important. It's a department ID, right? This is the common key between the two data sets. So this is what is you need to this is a primary requirement for doing joins. Now we'll go to the MapReduce. Let's understand how MapReduce supports join. Okay, the MapReduce, right? It provides two techniques for doing the joins. One, the first technique is called map side join. Okay. Second technique is called reduce side join. Okay, so you will be wondering, what is this map side join, reduce side join? Okay, the concept is very simple, right? The moment we see the word join, right, that means two data sets need to be available. So here map side join means the data sets are available on the mapper, in the mapper, to perform the join. Okay, so here let me call this as D1 and D2. Right, this is D1 data set 1 and this is data set 2. Okay, so in the map side join, so your data set 1 and data set 2 are available, okay, for the mapper. So the join is done in the map function itself. Okay. So join is done in the map function, in the map phase, or you can call it as a map phase itself. Join is done. Now you would be wondering, how can two data sets will be available? Okay, this is something we will understand. Okay, so but conceptually, let's just understand the meaning of these terms. Map side join means, well, okay, you have some data sets, those data sets are available in the map phase. Okay, we can very well join in the map side itself, means in the map phase itself. Now coming to the reduce side join, the meaning of that means, okay, both the data sets are not really available for your mappers, for single mapper. So here what you do, right, you need a reducer. So in the reducer, your D1 and D2, right, both your data sets will be available. Then you can use your join key and do the join. Okay, so here in the reduce side are available for the reducer, and then join is done in the reduce phase here. Okay. So any questions here, friends? We'll get on to the how part later, but at least the concepts at a high level. So we are looking at a very high level, like you can say, 3,000 feet high. Okay, just a join concept. Is it clear? Okay. Now we will go on to the actuals, right? How actually it is done, right? Okay, it's very easy to say, okay, make the two data sets available for the mapper, but we all have understood, right? Mapper will always read a split. From the split it always reads data from a single data set when it does not get data from two data sets. So we all know. So you would be thinking in your mind, how actually it happens. Is Mr. Karan right? Okay. Let me show you how it is done. Okay. So what happens here is, okay, in your map side join, so one of the data set will be one prerequisite for your map side join is, okay, so one of the D1, your either D1 or D2, one of them should be large and the other data set should be small. Okay. So one data set will be should be large and another data set should be small, and the smaller data set, okay, this smaller data set will be loaded into memory. It will be loaded into memory of all mappers. So all mappers, right? Suppose if your larger data set is split into 10 chunks of data, and you assume that your 10 mappers are running. So what these 10 mappers will have in memory is, they will have this smaller data set in memory. Okay. Once they have it in memory, they use a hash table or some collection API, and they do a lookup and they do the join. Okay. So this D2, right, this smaller chunk will be in memory, right, and it will be available for all mappers. Okay, it will be memory of all mappers, and this will be duplicated. So here another word is, it is duplicated, because a copy will be made available to each mapper which works on the split of larger data set. Now let's see the pictorially how it looks like. Okay, you can see here. This is a map side join. This is an example of map side join. Okay, whatever we are seeing is a pictorial representation of what I'm showing. This one. Okay, for the map side join, this is a pictorial representation. You can see this is your large table, okay, which is split into multiple splits. Split 1, split 2, split 3, split 4. Okay. So how many mappers are required to process 4 splits, friends? Radhakant and Vignesh. How many mappers? 4 mappers. Right? If you 4 splits, 4 mappers. Now you can see, so this is your 4 mappers. You need 4 mappers, and you can see the smaller table data. The data set which is very small, right? It will be duplicated across all your mapper nodes. So this is one node, right, on which your map task runs. This is another node. This is another node, and this is another node. So what happens? A copy of your small data set will be copied to each of these nodes. And the framework provides a mechanism to load the smaller data into memory. Okay. And once the data is in memory, so these tasks, when they execute, they do the lookup and they do the join. So here is the working of that. Okay, here is the working of that. First, let's identify the data sets. So this is my large data. Okay, this is, let me call it as D1. Okay, and this is a small data set. Okay, D2. Okay, D2 is small. So which will be loaded into memory? D1 or D2? In the map side join, which will be loaded into memory? Okay, it's a D2, not D1. D2 you can see. So you have a, okay. So these are all the multiple mappers, right? Multiple mappers which work on the split. You can see, call this as okay. This as they call these record, whatever they call it as a record. Can call them as splits. You can have, you know, these mappers work on these splits on each split of the large data. Okay. So these mappers, what they have is, what they do is they load this smaller table data into memory. So this hash table is it's memory. Okay, so this is a memory. So they use, in order to load this D2 smaller data set, it uses a feature called as distributed cache. Okay. It uses the framework. Okay, Hadoop provides a framework called a distributed cache. Using this framework, we can load the smaller data set into the memory of the mapper nodes. So this is how conceptually we do the map side join. So here, what is the dependency for us in order to work on this? So we need to know the distributed cache. Okay, this is the feature that it uses. So for now, okay, we will just understand the concept. Once we learn about the distributed cache, we'll implement the map side join. Okay. Now we will look at the other join technique. Okay, we'll proceed on to the other. Okay, the other join technique is a reduced side join technique. Reduced side join technique, we go for it when we have two large data sets, whatever the D1 and D2, right? If they are large, then we go for reduced side join. So here, okay. So some questions should occur to your mind, right? When we wrote our MapReduce program, it read the data from only single source. Yes or no? We had one mapper, right? Okay, types of MapReduce program. So what we wrote so far, we wrote one mapper, we wrote one map reducer, right? So it was always taking a data from one data set. Now the question is, so you would be wondering, how will I pass, right, D2 to my mapper? Yes or no? This is the question you must be having in your mind. Okay, so that's a good question. Now this will allow me to introduce a new topic. So whenever you write your MapReduce program, friends, so don't think that you always follow only this technique, right? Just one mapper, one reducer, right? When you do it, right, you can do it in multiple ways. One technique is in one of the approaches you will write you will read the data from one source, right, and you write a mapper and you write a reducer. In some cases you'll write only it will be only map reduce job. Means you have a code only for the mapper, you don't require a reducer at all. Okay, you don't require a reducer at all. Okay, for the de-identification example, did you guys try out this de-identification assignment? How many of you completed? In the last class assignment, how many of you have completed? Amarnath, Amit, Anand, Ashutosh, Chandan, Gaurav, Jyoti, Nishit, Radhakant, Raji, Urvi, Vignesh. Okay, Amit has done, Raji has done. Anybody else? So how many? So when you did this, how many reducers did you use? What was the reducer count? When you did the de-identification example, how many reducers did you use? Okay. 0. You don't need a reducer at all, right? You are for each record you are doing some translation. You are not doing aggregation, so you don't need a reducer at all, right? So this is an example for map reduce job. Okay. Now there is another way of you can write a map reduce job. You can have two different mappers reading the data from two different sources, right? But you can have a single reducer. Okay. You can have two mappers reading from two different data sources. Okay. But you can have a single reduce, or you can do the only one aggregation. Okay. So this is third way of writing your MapReduce program. Okay. Another way of writing your jobs, MapReduce jobs, is mapper followed by reducer, okay, and it's called as a chaining. So the output of this MapReduce, the first MapReduce program, will become input for your second MapReduce program, okay, and okay, let me call it as M1 R1, M2 R2, okay. And this the output of second MapReduce program can become an input for third MapReduce program. Okay. So this technique is called as chaining of MapReduce jobs. So this is an example for chaining. This is an example for multiple inputs. Okay, multiple inputs MapReduce job, meaning you have multiple mappers reading from data from different sources. Okay, this is a map only job, and this is a regular MapReduce job. So out of these 4, 1, 2, 3, 4. So for the reduce side join, so which technique will I use? Which type of MapReduce job will I write? Can you make out? I've given you enough explanation. So now tell me, for reduce side join, I have two data sets. Okay, if I have two data sets, so which MapReduce job will you use? Amit says, okay, so the answer is obviously between third and the fourth. So now you have to intelligently decide. Okay, Radhakant, you are right. Amarnath, you are right. Raji, you are right. Ashutosh, you are right. Gaurav, it's not chaining, Gaurav. Just think about it. What did I say for this? This is multiple data sets, right? Single reduce. Multiple data sets, but a single reducer. Okay, the option is third. Okay. So this is the technique. So we'll have multiple mappers for a single reducer. So using this technique, we'll do this. Now, in order to understand the reduce operation, right? So what we will do, we will take a look at some statement. We'll take a problem and solve it. Here what we have in this example is, I'll just read out. Okay, so we have the transaction. This is okay. This is an example wherein we have transaction data. A transaction can be, think of, all the purchase transactions. Think that it's an e-commerce use case wherein we have customer data and the transaction data. Customer data will have the personal details of the customers. Transaction data will have the purchase details of the customer. Okay, so here you have the transaction data and customer data, and typically what people do in e-commerce company, right? They run promotions, right? They send some discounts, they send some offers. So let's assume that this company, whichever has this data, it has decided to run some promotion. Now this special promotion they want to target only for the people who have done a lot of purchases. Okay. So what the sales team wants us to do is join the customer data with the transaction data, okay, and provide them the customer ID. Okay, provide them the customer ID and the total the transactions that they have done and total amount they have spent. Okay. Assume that this is the report that they are asking. What do we have? We have the transaction data and the customer data. What business wants? They want us to join these two data sets and provide them the customer details, right? Customer details in the sense and the customer IDs and the amount of transactions they have done, basically amount of money they have spent and the number of transactions they have made. Okay. So this is the use case. So let me show you the data, how it looks like. Okay, so this is the customer data. It has customer ID, the first name, last name, age, profession. So this is the customer data. Let me show you the sample data as well. So we have customer ID, customer first name, second name, age, profession. Now this is a transaction data. What do we have? Transaction ID, date, customer ID, amount customer has spent, category, product, city, state, and some information. Basically this contains the transaction purchase user has done. Let me show you the transaction data which contains the transaction user has done. So this is the one, the data. Okay, the format of this I showed you there. Okay. Now let's assume that we have been assigned that task, right? Now let me, just for simplicity, I will take only 2-3 fields. Okay, I request everybody to be attentive. So I need your help. Okay, it will be interactive. The way I will be solving is, okay, I do not really jump onto the code and show you the code. So here I want everybody to intelligently decide, okay, the mapper input key and mapper output key, mapper input keys and values, and the mapper output keys and values. Okay. So please everybody roll up your sleeves and pay attention. Okay, I will be just stating the problem. I need your help here to come up with an algorithm. So what does our customer data contains? Customer ID, okay, name, age, something. We'll just keep it simple. And then we have the transaction data. In the transaction data, what do we have? We have a transaction ID, okay, and we have a customer ID, and we have the product purchased, and we have amount user has spent. Okay, what is the report we need? In the report we just need customer ID or customer name, the amount he has spent, total amount he has spent, and total number of transactions. This is what we need. Now everybody, all of us have decided, Amarnath, Nishit and Vignesh, so we have decided to use multiple mappers and multiple mappers and single reducer. So this is the approach we have decided because we have two data sets. Okay. Now let's call, so this is M1 and this is M2. Okay. M1 is for customer data. Okay, this is M1, let's assume it is for customer data, and M2 is for transaction data. Now what we will do, we need to write the mapper function for M1. Okay, this is the map1 function, so which takes keys and value, right? Assume that it reads this. Okay, M1 is for the customer data. Okay, assume it reads this data, right? We'll call it as an array, right? Split V into array of words. Okay, assume we get all this properly. We take the use proper indexes and extract all this customer ID, and basically we extract the customer name, and okay, customer name here is, it is a 0th first index. Okay. So what should be your output of okay, so what should be the output of okay, this is the customer ID is equal to array of 1. So I need your help here, friends. So what will be your mapper output? So what will be the key value of your mapper output? Everybody, please, what is the first key of your mapper output? What did we decide in the join? Everybody, I want everybody, everybody in the class to answer this. I mean, if some of you are not answering, then means you have not understood the concept of join. What did we say when we want to join? What is required? Common key. Okay, where is the common key? Common key is the customer ID. Okay, yeah, I think by mistake I have changed the index. It is 0 and 1. Sorry, thanks. Thanks, Raji. It's a 0 and 1. So this is your customer ID. Okay. So what is your output? Output is key is customer ID. Everybody agrees. And what is your value? Customer name. That's correct. Very good. Thanks. Now coming to the M2. Okay. Coming to M2, that's a mapper 2. So what does it take? It takes the transaction input. It is also splits the value into array of words, and here also we need a customer ID. Here the customer ID is 1. Okay. And we have the total amount. So total amount is in 0, okay, 0, 1, 2, 3. Okay, it is 3. So what will be the output of your okay, what will be the output of your mapper 2? Everybody, so what will be the output of this mapper, second mapper? It's a customer ID, and it's not amount, it's amount, sorry friends, it's amount. It's not total amount, will not have amount. So it's amount. Okay. Now we have a problem, right? When it comes to the reducer, so let's assume that this is what we, okay. One of our friend is saying, Urvi is saying product. Do we need product? For the report, Urvi, do we need product? So look at the report we need. What is it saying? Do we need product? We don't need. It is just asking us the total amount and total number of transactions. We don't need product. Now here is coming to the reducer. So here is the problem we'll have. So in the reduce, right, it has key and a value, list of value. So we all agree what will happen for all the customer IDs, right? Key will be the customer ID, and your list will have the name and all the amounts, right? Amounts of the purchases that he has done. But the problem with this approach is we'll not know which is amount and which is name. Yes or no? Right? Unless we do some exception handling. And that we don't want to do. I mean, that will be a bad way to write code. Can we figure out from this list which value is the name and which value is amount? Difficult. Right? Yes or no? So what we do for that, we'll do some, we'll do a workaround, right? Either, okay, this is a simple way of doing it. I'll tell you other way of doing it also. Okay, so what we do, we will prefix. Okay, we'll prefix with customer. Okay, whenever if it is a customer data, we'll prefix it with this. Okay, use some delimiter, any delimiter which you want. You can use tab, hash, anything. So what we are doing, we are prefixing with, for the customer name, we are prefixing with this, and for the transaction, we are prefixing with this. Okay, trans. It's a constant. So what we do now? Now in the reducer, what we do, right? For each for each value in the list, what we have to do? If value contains name, okay, if value contains name, we'll declare some variables, customer name, right, and amount, total amount. If value contains name, customer name is equal to, you can pass the value, write some method called get name, so which will take the value and return us. What get name will do? It will just take this here, right? Parse it and return us the name. Else, okay, if value contains amount, if value contains amount, what we do? Total amount is equal to amount plus this, right? This is what we do. Plus get amount. And what will be the output? So output is, output will be the customer name, and you can calculate the number of transactions as well. You can declare one variable called number of transactions, right, and you can keep incrementing it here. Initialize it to before, and you keep incrementing it. So this is your reducer logic. So your customer name, and then you can output so your total amount and number of transactions as a value. So is the join logic clear to everybody? How we wrote our own, how we wrote the two mappers and how we developed our reducer. Now understanding the code is very simple. I mean that's how we do the reduce side join. So let me show you the reduce side join. Chandan says revisit please. Yes, Chandan, I'm doing it now. Okay. So Chandan, for the reduce side join, right? We took this approach, right? We have two data sets, and the data sets, both the data sets will be available in the reducer to do the join. Okay. So we are taking, we are adopting this way of writing MapReduce program because it allows us to use multiple mappers for different data sets. Okay. So we have two mappers and and one reducer. So let's look at the mapper here. So mapper 1 is responsible for consuming So this has the customer data and the transaction data. This is responsible for handling the customer data. So mapper 1, what it is doing, it's reading the customer data and it's outputting the customer ID in the customer name, okay, with some prefix, because this is just to identify which value is what. Okay, and in the mapper, it is reading the transaction data and it is outputting customer ID and the amount. And we are prefixing the amount with some constant. This is to identify that this contains amount. Now in the reduce, what we are having, we get this, the key is the customer ID, right? And the list will contain the name and the amounts. So what we are doing, we are iterating over each value in the list and we are extracting the name, and we are calculating the total amount. Okay, and we are finding the number of transactions as well. After we calculate all that, we output the customer name and this output name and total amount and number of transactions. This is what we do. Is it clear, Chandan? Now let me show the code also. It will be more clear. Abhijit, I'll explain that, Abhijit. I'll explain that. I got your question, Abhijit. I'll explain. So this is the join, friends. So let's go to our driver class. The driver main method it has. So here it uses the latest APIs. Okay, if you remember, I think I showed you in the last class the difference APIs, right? The old API and the new API. Okay, no problem. Let me tell you this new APIs. So in the last class, what all did we use? We used MapReduce base, right? So in the older version, what we use? We use the MapReduce base, right? And we use the job conf, right? And we use the job client, and we use the output collector. We use reporter. So these are the different APIs that we use. So this is the older version of Hadoop that was like from starting, right, till 0.18 and till 0.20. So this was used. Okay, after 0.20.2, so this was introduced. Okay, they had the concrete classes like mapper, reducer, and they created what they did in the job configuration API. They splitted, okay, that into two job and configuration APIs. Now for the job client, we have okay, using the job itself, now we can submit the job, and for the output collector and reporter, they have combined, okay, and they call it as context. So this is from this 0.20.2 onwards, but it is all backward compatible. All the APIs that we see here, they are all backward compatible. Now we will use this. We'll use these APIs. Okay. Here you can see this is the new API it uses. Here we are using the configuration and job. So earlier it was job configuration. Now it has been split into job and configuration. Okay. So we are creating an instance of configuration. Okay. So this we are passing it in our job, and our job we are setting our driver class, reduce side join, and we are setting our reducer class, and we are setting our output key, output value. Okay, and you can see this is important. The multiple inputs API is what we are using to, okay, in order to write two mappers for our MapReduce program. So we need to use multiple input API. So multiple inputs API, using this we map the input and the mapper class. Okay, you can see this is the multiple input for the first data source. Okay, so this is the input format, text input format, and this is the mapper class, customer mapper. And we use again multiple inputs for the second. Okay, for the second source, this is the input format, text input format, and this is the mapper. And this is the location where the data will be written. Okay, path, output, path. So this is the location where the data will be written, and okay, and this is set using the file output format. And you can see here, so we are using the job API itself. Job here, job API in order to submit the job. Okay, wait for completion. What it does, you can see it submits the job to the cluster and wait for it to finish. Now let's look at what we are interested in is customer mapper and the transaction mapper. Let's look at it. You can see previously it was extending MapReduce base, right? Now it extends mapper object. So that's what we saw here. So before it was a MapReduce base, now they have a concrete classes, mapper and reducer. See, it extends a mapper, and these are the input key, input value, output key, output value types, and this is the parameter for your map function, key and value, and this is the context. Context responsible for the duties of output collector and reporter. Output collector collects the mapper output, reporter is for tracking the progress. Similarly, now context is playing both, role of both. You can see here what we are doing. So look at the source pseudocode here, it's easy. M1 what we did, you can see here M1, this is M1, yeah. You can see what we did, we read the record, right, and we are outputting the customer ID and the customer name, same here. You can see the card 0 contains the customer ID and this contains the customer name. Okay, and this is a second mapper. This also reads the line, splits into array, and then outputs the customer ID and the amount. Okay, with prefixing the transaction. In the reducer, if you can look at this reducer, in the reducer what we are doing, you can see it is getting the key, list of values and the context, and here it is implementing the reducer API. This reducer is part of the package. You can click on this, Arc, Apache, Hadoop, MapReduce. Okay, even your mapper is also part of this package. So first what we are doing, we are initializing this name and the total amount and the count. Okay, we are iterating over the values and we are checking if it is a transaction. We are calculating the amount and the number of transaction. If it contains the customer name, we are extracting the customer name. Okay, and then we are outputting the customer name and the total number of transaction and amount. Take a minute or take 30 seconds, right, and you can take a look at the code. Just leave it like this. Take a look at the pseudocode and take a look at the code. So once you are done, do let me know. I will show you the execution. So shall we go to the execution part, friends? Shall we see the execution? Okay, let's see the execution. Name and string which contains total and count. Yes, Vivek, that's what it is returning. You can see here the output. It is returning. It is combining this into one string, right? This is the total amount and one contains the number of transactions, and this is outputted for each customer name. Let's see the execution now. Okay, so first we need to see if this exists. Class for input data. Okay, we don't have it. Let's create this folders. reduce side. Let's create the first for the customer data folder for customer data. Created folder for transaction data in HDFS. Created. Load the data, customer data into HDFS. Loaded. Load transaction data. Done. Then see if our jar file is in the local drive wherever we are. So okay, it's in class 4. So we have here. Now let's run this program. Okay. So Hadoop jar. This is our jar file. This is our driver class, and this is the customer data for the input for our first mapper, and this is the transaction data input for our second mapper, and this is the reducer output location. Okay. Now you can see this. You can see this. Can see there are 2 mappers running, and one for each of our input file, and this is output. Okay, so let's look at the output. The output is in class 4 output MR join. Okay, you can see this. User Christina has done 8 purchases and she has spent $651. Okay, we can see the data here. So we have user Christina, right, and who has done a lot of purchases here. Okay, so you can see there are so many transactions he has done. Any questions? Abhijit says, let me read out the question from our friend Abhijit. Abhijit says, one confusion, I understand reduce side join. It will use multiple mappers and single reducer. So what about map side join? Will that be used in the same approach as we would need 2 data sets? Okay. So quick, can you answer these questions, friends? In the map side join, right, when we have 2 data sets, one of the data sets will be small. So which data sets will be loaded into the memory of the mapper nodes? Large data set or small data set? Which is small data set. I will show you that after the break. Okay. We'll see that we use the distributed cache feature and load the small data set into memory. Okay. So Jyoti, any questions? Do you have any doubts? Jyoti, Amarnath, Vignesh. Vivek says, I guess in the reducer we can order it by our total amount. Yes. Gaurav says, can we use map side join in this case? Yes, we can do that as well. I mean, if the customer data is small, we can apply map side join as well, Gaurav. Okay. So just I was okay. I'm showing how to use a reduce side join. Okay. Now let's take a break. It's 8:34 now. Okay, and we'll take a break for 10 minutes. 8:44. Okay, let's come back by 8:44. It's 8:34 now. Let's be back by 8:44. Okay. Friends, I'm back. Can you all quickly confirm? Amarnath, Amit, Anand, Ashutosh, Chandan, Gaurav, Jyoti, Nishit, Radhakant, Raji, Urvi, Vik. So before the break, before the break, we talked about combiners, partitioners, right? And we understood the join techniques, map side join and the reduce side join. So let's proceed further. Let's understand other advanced features in the MapReduce. Okay. We'll talk about now about the data types. Right. So far, what are the data types that we have come across that we have used in our program? I mean, if you look back, I mean, we have used the text, we have used the long writable, int writable, right? So these are the different data types that we have used. Okay, but one common feature among all the data types that we have used is in all of them, most of them implement writable. Okay, all of them implement the writable interface, and most of them implement writable comparable interface. Okay. Now you will be asking question, Karan, we have a long, why do we need long writable? Okay, this can be an interview question as well, right? Most of you have this question. We have Java long, so why do we need it is a wrapper around the primitive type long, so why do we need long writable or int writable? Okay. So there are reasons why they have created this. If you look at the framework, right, we have so many phases: map, split, map, combine, shuffle, reduce. So what is happening in these phases, right? These keys and values, they are passed from one process to another process. Okay, so when they are passed, so what happens? Sometimes the object, right, your key and value, right, these objects are written onto the disk, right, and then they are transferred over the network, and then your reducer receives it. Okay, and this is your mapper output. Let's assume that it outputs key and value. So before it is sent to your reducer, it is written onto the disk, and then it is transferred over the network, and reducer receives it. Now these objects, right, I mean, so whenever they are saved to the disk, right, this process it is called as serialization. Okay, so in the memory the representation of the object will be different. So in order to object to save the state, it saves this in a different form. Okay, so this is called as serialization. The guys with the Java background, are you all familiar with the serialization concept? Okay, serialization and deserialization. So deserialization is a reverse process. You know, building the object state from the saved state. It is called as a serialization. Okay, saving the object state onto the disk, or sending it over the network. It is called as serialization. So since serialization and deserialization is required here because of the different phases, because of the way the MapReduce model works. Okay, so we need some APIs which support this serialization and deserialization. So this is supported by the writable. So that's why this is there in the whenever you implement a writable interface. It will ask you to implement methods for serialization and deserialization. This is about the writable. So this is the difference between long writable and long. So this is this has method for serialization and deserialization, and these methods are used by the Hadoop framework. This is about the writable interface, and this is the base interface for the values. Now coming to the comparable interface, whenever you implement a comparable interface, you implement a method called compare_to. Okay, so compare_to is mainly for comparing two objects, to understand whether it is a smaller, bigger, or same. Now, can you tell me in which phase sorting is happening? Is sorting happening anywhere in the MapReduce? In which phase? If it is happening, which phase? And what is getting sorted, key or value? No. Let's be clear with this, friends. Yes, it is happening in the shuffle phase. I agree. What is getting sorted? Key or value? Vivek, it is key, not value, right? It is not value, friends. It's key, right? It's grouped, it's sorted and grouped, right? It's key. So that means your key should implement comparable interface. Comparable interface will have a method to compare objects. Okay? Whenever it sorts them, it needs to know. The framework will not know which is bigger and which is smaller, right? So we have to write an implementation for that. So it will be there in the comparative method that you will implement when you implement this interface. Okay. Now, is comparable interface required for values? Comparable interface, is it required for values? Comparable interface is mostly for sorting. Okay. Is it required for values? No, it is not required. It's okay, it's only for keys. So you can see it is for keys. If you want to create your own custom data type, if you create your own custom key, so what if you create your own custom key, which which interface will you implement? If you create your own key, which interface will you implement out of these? Writable, comparable, or writable? Okay, you implement writable, comparable. If you create your own data type for your value, so which interface will you implement? It's a writable, that's correct. Okay. In a while, we'll create our own custom key and custom value. Now what is the recommended reading for you guys? Assignment. How many of you are planning to appear for certification? Cloudera, Hortonworks. Okay, Amarnath, Vivek, Chandan. Okay, so most of you. Urvi, Anand. So friends, I mean, if you are, you need to take it something seriously. How many of you have bought this book, Hadoop Definitive Guide? Urvi has got it, Radhakant has got it, Amarnath has got it. Nice. So you guys need to, I mean, the ones who have, ones who are appearing, it is must. So you please refer Hadoop, Apache Hadoop documentation for the complete list of data types. Okay, I have in the class we talked about long writable, interwritable, right, and text. There are many more. So you go to this website and read about them. Okay, third generation. Yes, third edition. Now coming to the input formats. So what is the role of input format? Input format is okay. Quick question here. Let me see how well you have understood. We listed some phases right here. So in which format is it related to? So in which format does the input format comes into picture? In which phase? The question is the input format, right? In which phase does the input format comes into picture? I mean, if you have done the revision of last class, it's easy to answer. Vivek, maybe you have missed the question, so for you it will be difficult to answer. Amit, you are correct. Raji, you are correct. Okay. So guys, we spoke about this last class. Abhijit, Amarnath, Amit, Anand, Jyoti, Chandan, Gaurav, can you answer this? Just take a guess. Input format, right? In which phase is it used? So basically, your input format is responsible for generating keys and values for your map, right? It is basically in the split. This is the one input format. What is responsible for your file? Read the file and generate KV for your mapper. Okay. So this is the role of your input format. It is the one which creates a split and generates a key and value for your mapper. Okay. So somebody can ask you questions like this. You know, what is the role of input format? Okay, don't be surprised. So now you will see here. Now you can easily relate. You can see the input from the input file. The input format creates the splits. Okay, it's used to create splits, and your split is passed to a record reader. So what this record reader will do? It will read each record and it will generate key and value. Okay, your record reader it will generate. It will read each line, each record, and it will generate key and value for your mapper function. Okay, for your map function this will generate. So this is what is the role of input format. Okay, so what input format did we use so far? Text input format, right? So what did it generate? What key did it generate? The text input format. A, byte offset. B, the first word till the delimiter. What did the text input format generate as a key? It generated the byte offset, right? So there are other formats like key value input format, okay, inline input format. So there are other types of input format. So you just need to be responsible and understand what it does. So here is the different types of input formats. Okay, combined file input format. If you have too many small files, you go for this combined file input format. It's an abstract class. You need to implement a couple of methods in this. Okay, you cannot use it straight away. Okay, this is the combined file input format. This you use when you have too many small files. That's why it says the word itself, the name itself says combined file input format. And then you have a text input format. This it generates a byte offset and the line as a key value for your map. And key value input format, what it does, if you specify the delimiter, the first word till the first occurrence of the delimiter, it will treat it as a key, right? And remaining thing, anything after the delimiter, it will treat it as a value, and that will be passed as key and value for your map function, right? And this is the value. This is how the key value text input format works. Now let me ask you a quick question here. I'm calling it as a key value input format. Okay, let's assume I have a record like this. I have some data which has year and temperature, and I'm calculating the average temperature for last 100 years. Okay. Now this let's assume we use key value input format as your input format, and you specify the delimiter as comma. Now what will be your key and what will be your value? This is your input data and you are using key value input format, right? And this is the delimiter, and what will be the key and what will be the value? Okay, key would be year, value would be temperature. Okay, so if your input data has okay, if your input data contains key value, friends, then you don't need to use text input format. Go directly with the key value input format. Is the difference clear between text input format and key value input format? Chandan says no. Chandan, is the difference not clear? Let me explain. What is this? This is key value input format. Key should be always unique. See, unique, think about in the model, man. Think about the model. The model says, Vic, key should be unique for your mapper output, right? For the model, if you are solving a problem, you definitely want to be unique. I mean, for the input, I mean, if you have a data unique key, then you can go for a key value input format, right? It depends on the use case. It does not mean that you can always use this. Is that clear? Is it clear, Vivek? Okay, Chandan says, Chandan, white text. Text input format. Let's understand what for the same data, if I use text input format. So friends, can you tell me what will be the key and value if I use text input format? Here the key is, previously key was this, right? The year and temperature. So what will be, if I use text input format, what will be the key? Mapper input key. Okay. Key will be the byte offset. Correct. Value will be this entire line. Okay. So Chandan, is it clear? See, text input format is the default input format Hadoop provides. Now there are other input formats also. This is an inline input format. Inline input format, what you can do, what it does is, you can specify the number of lines you want in your split. Okay. If you specify number of lines as 30, then each split will have 30 lines, and that 30 line will be given to your each mapper. So each split will have 30 lines. So this is an inline input format. This you can use to create splits. Okay, now basically fix the number of lines in the splits. And this is a sequence file input format. This this is the input file format that you can use to read the files that are stored in a sequence file format. Today we will understand the sequence file format. And these are other variants of sequence file formats. Okay, there is something called as a DB input format also. This you can use if you want to directly read the data from an RDBMS. So this is the hierarchy of the input formats. Okay. So as an exercise, what I would request you is try an example of key value input format. It is there in assignment. In LMS it is there. Key value input format. Try this, and if possible, try this also, DB input format. Coming to the output format. So output format is responsible for taking the reducer output, right, and writing into the file. So here you have this is the reducer which produces the output, right? You have a record writer which writes the data into the output file. Okay. So this is the role of the input format generates key value pair. Here this writes the data, the reducer output to a file, output file. Now let's look at the output class hierarchy also. It also has a similar hierarchy. There it was a file input format. So here it is file output format, right? And you have different variants here. This is the text output format. This is the text output format, and here you have a sequence file output format as well, which writes the data in the sequence file format. We will use today the sequence file output format. Okay, and you have a null output format also. Okay, in the null output format it will not write anything. And you have a DB output format which can write the data directly into RDBMS. From your MapReduce program you can directly write the data into RDBMS using the DB output format. And so this is okay. These are another set of output formats. So for the guys who are preparing for certification, okay, so you refer this, each of them on the Apache website. Okay, Apache documentation for the input formats. Okay, at least take a look at them once, what they do. Because I get questions towards and saying, Karan, I'm preparing for certification, I need tips. Okay, so I'll be giving tips during the class itself. Please pay attention to all this assignment. Okay, so this, if you follow whatever we discuss in the class, I'm 100% certain that you will crack any certification. I mean, it's not really rocket science. Can I get a smiley? Okay, thanks friends. Okay, so let's move forward. Let's talk about custom input format now. Okay, let's talk about custom input format. So let me state a problem for that. So this is the, okay, here you see the data. Here you can see this data here. So this data has this is the data, sensor data from some sensors. It has sensor ID, timestamp, status, and it has value and value too for that. Okay, for this sensor type. Okay, for this timestamp. Now, so what we want to do is, in this use case, we want to create a key which consists of these three fields. Okay, so we want to create a key which consists of these three fields, and we want to create a value which consists of these two fields. Okay, and what we want to do in our MapReduce program is, so we want to just output the values of sensor ID or sensor type A, and we want to filter out anything other than we want to filter out other records. Like if a sensor type is B or sensor ID is B, we want to filter those records. So we just want to output, okay, the values for the sensor ID A or sensor type A. Okay, this is what we want to do in our MapReduce program. Okay, now the question comes. We are saying that for our mapper we want to create a key, and the key should have these three fields, and we want to pass these. We want to create a value which should contain these two fields. Okay. Now, can you tell me what all? Okay, how many classes or what all classes do we need to write? Okay. Can we start listing down? Can you give some inputs for me for this use case? What all classes we need to write? Okay. Or what are the different types of components we need to create? Okay, you can say yes or no. Do we need to create a custom key? Yes or no? Because our requirement says create a custom key. So when you create a custom key, which interface will you implement? Okay, which interface? It's a writable, comparable, or writable? Okay, writable, comparable. Very good. and we need to implement, let's call it as my key. Okay, custom key, I'll call it as my key, and we need to create a value, a custom value. So what should it implement? Writable, that is correct. Now we said this key and value should be passed to our mapper function. How can we do that? Who is responsible for generating key value pair for our mapper function? Who is responsible? In the last slide we talked about that. Who is responsible for generating key and value pair? Take a look at it. Who is generating? Here. Which is the class, right? Which is the which is API, which is generating input format, right? It internally calls all this stuff, right? Record reader and all. But overall, which is responsible? This your input format is responsible. This is the one which is responsible for generating key and value. Okay. From the splits, yes, one of the steps is it creates splits and then it generates key and value. But this is the one which is responsible, right? So do we need to create our own input format? Yes or no? Do we need to create our own input format? Yes. So we need to create our own input format. Now, do we need to create our own record reader? Because internally it create an instance of record reader. We said, it passes the split to a record reader, and record reader generates key and value pair. Do we need a record reader as well? Yes, we need a record reader because this is the one which is called by the input format to generate the key value pair. Okay. So these are, along with this, we need to create one map class. So these are the different classes that we will be writing. So let's start writing them, or let's take a look at them. So this is our driver. In addition to that, we need one driver also. So you can see this is a driver. So in the driver, we are creating an instance of job, right? And we are setting our, we are registering our driver, setting the name. We don't need reducer because we are just filtering the records. And this is our mapper class. And okay, this is, we are setting the output key and output value. And this is the input format. Okay. So let's start with input format. Let's start with input format. Input format is the one which is responsible for generating the key value pair using record reader. And this file input format and the file output format we use to set the input location and the output location. Let's look at the input format. So you can see this input format, it extends file input format. Okay. And it is using, what it is doing, create record reader method it is implementing, which takes these parameters, split and context, this task attempt context, and it is returning this record reader. This is a custom record reader that we have written because this is the one which is responsible for creating our key value pair. So let's open this. Okay. So now you can see this is a custom record reader which understands the input data and gives key value pair for map process. Okay. Now this record reader, so it has my key, my value. So now let's look at this my key. This is a custom key which implements a writable comparable interface. Okay. As a part of writable interface, we have to write methods for serialization and deserialization, right? Okay. So this is the constructor. So these two are the constructors. Now read fields and write. Okay. Read fields and write. Let me write down. This is important. Read fields and write. Okay. So these are the methods which take care of serialization and deserialization. Read fields means deserialization. Write fields, write means serialization. Okay. So whenever you implement a writable interface, you need to implement these two. Okay. You can see here, read fields. For that, it is taking a data input. Okay. This is data input. What we are doing, we have declared 3 fields inside our my key. Okay. Those 3 fields are sensor type, timestamp and status. here. Sensor type, timestamp, and status. And our value we will see in the next class. Okay. And what are we doing? In the read fields, this is the serialization method. We are using, this is of type text. So we are using the read fields of the text itself for to provide the serialization method. Okay. Sensor type dot read fields, and similarly we are providing the serialization method implementation for timestamp and status. Okay. This is read fields, and okay, sorry, it's a deserialization methods. Read fields means deserialization. You are building the object. Okay. This is the write. Write is serialization, saving the state. You can see we are using the write implementation of the text. Okay. And then since it is a key, there is this comparative method which is used for sorting. Okay. And then, so yeah, that's it. That's it with respect to the my key. Okay. So it has to implement three methods: read fields, write, comparative. Now let's look at value. So value, so here I have implemented writable comparable. You can change it, you can change it only writable. Okay. When you have to only, if you make it only writable, then you implement only read fields and write. Okay. What does my value as? My value as value 1 and value 2. Okay. So this is what will be set as the value for your mapper class, for your mapper method. Okay. So this is our value class, and now coming back, okay, to our record reader. So there is a method called next okay, get, let me just see. Yeah, this is the next key value. So this is the one which gets continuously called, right? Whenever it works on a split, the record reader continuously calls next key value, on whatever the key value generated, it will pass that to your mapper. Okay, you can see what it does. Okay. You can see what it does from here. Using the reader, it gets the current value, that's a line. Okay, from the line, it is splitting it into array of tokens. From the array, it is building our key. You can see here, key dot set sensor type, key set timestamp, right, and key dot set status. So it is setting the key, and then it is setting the value. Okay, value and value 1, value 2. So not this next key value is the one that gets continuously called when it works on a split. So this is our record reader. Okay. So now we need to take a look at our mapper class. Now let's take a look at the mapper class. So mapper class, what it does? It's calling the, we can see this map method. It is taking our custom key, custom value as a data type for the key and value. Okay, this is a custom key and this is a custom value. Okay, and these key values are passed by our input format by calling the record reader. And this is the context. Context is a later version, in the latest version of Hadoop, it plays the role of output collector and reporter. Okay. Well, now we can see here we are getting from the key we are extracting the sensor type. From the sensor type, using the sensor type, we are filtering records. What we are saying, if the sensor type is equal to A, then we are writing the values. Okay, value 1 and value 2. So with this, so we saw the implementation of all these class: my key, my value, the input format, custom record reader, custom input format, then the mapper, then the map, and the driver. So let's see the execution of this. Let's create the data custom input format folder. So we created the folder. Now let's add data. Added the data. Okay. Now let's call let's invoke our MapReduce program. It's submitted to the cluster. So this is our jar file, contains our MapReduce program. This is our driver class, and okay, and this is our input data. So input data, let's look at it. Class 4 input data custom input. So class 4 input data custom input. Okay. So this is the sample data. Just to understand how to write our custom input format, right? Custom record reader and custom key, custom value. So just for the understanding purpose, I have created only the sample 2 rows. Now let's run this. Now let's verify the data. It is in class 4 output. You can see it has outputted only the values. Okay. You see the input data here. So what is the expected output of our MapReduce program? So we wanted only the value 1 and value 2 for the sensor ID A. Okay. So what is the expected output, friends? Is it 2223 or 3334? Okay, let's look at it here. It's 2223. Nishit says, will you be sharing all the sample in LMS or Google? Yes, it is there in LMS, and anything that I use in the class, you'll find it in Google Drive also. Do you have the link to Google Drive, Nishit? Can you take a quick look at it? I have added for class 1. Oh, you don't have it? Okay, let me share it with you. Okay. Maybe towards the end, please remind me. I will share it. I must be having it. Let me share it towards the end. Okay, let me pull that out and share it with you. Okay, so with this, we are. So friends, some of you have, if you have it, can you send it over to me? If you have that link, if you have bookmark. Okay, thanks Vivek. Vivek has sent it. Thanks Vivek. Okay. So Nishit, please take it. Take a look at it. So I have added. You will see, 3 folders there. So with that, we understand the working of the custom input format, custom record reader, custom key, and custom value. Now let's move on to another interesting topic. Okay, let's move on to another interesting topic, that is MR unit. Okay, how many of you heard of JUnit? How many of you at least have heard of it, not used, just heard of it? Okay. Nishit, Vivek, Amarnath, Jyoti, Rajiv, Urvi, Vivek, Ratakant, have you heard of it, JUnit? Okay. So JUnit is a unit testing framework. Okay. So it is a unit testing framework. So some of you would be wondering, what is it? No, it is not Ant, Amit. Ant is a build tool. Okay. JUnit is a unit testing framework. So what is the meaning of your unit testing framework? Let me explain you in a layman's language, right? So whenever we develop, we write something, what do we actually do? We automate something, right? We write a process which machine can execute, right? So basically we develop when our code is nothing but some process, okay? our code, whatever the developer writes, it's a process. It is something that machine executes for the input that we provide. Okay. So this process, what does it take? It takes some input. Any process, it takes some input and it gives some output. Right? Now when we developers write the code, right, for this process, we are always certain, we are biased. We think that it always gives us the expected output, right? We always think whatever we write is correct, and whatever the output we get from this process is always the expected output. But most of the times there will be bugs. Most of the times, I mean 40%, 30% of the time there will be bugs in the system. Okay, we'll be not taking care of some scenarios. Okay, so in order to test your process thoroughly, there are some frameworks. So what these frameworks will do, they will not know what code you have written, but they will know what code, what it should do. Okay, meaning for the given input, right, they will know what is the expected output. Okay, example, input is 1 and 1. Let's assume that you have written a sum program. So what is the expected output? Let's assume that we have written a process to calculate sum of two numbers. What is the expected output? 2, right? So we have some frameworks which we can use, for which we can say, we can configure, okay, this is the input and this process should give this as an output. Okay. Now what that framework will do, so this is what we specify for our framework. We specify, okay, this is my input and this is the process framework you should test, and after you test it, it should give this as an output. For example, we have something like 1 1, add is a program, it should give 2. What the framework will do, it will execute the process for the given input data, and it will collect the actual output. Okay, it will collect the actual output and it will compare with the expected output. Assume that your actual output you got was 3 and the expected output was 2. So what will happen in this case? Will the test case pass or fail? Okay, your test case will fail because it is not matching. The actual output we got is not matching with the expected output. Okay, so this is exactly what you do with the unit testing framework. Okay, let me quickly summarize what do we do with the unit testing framework. Using unit testing framework, right, you can test your code. Okay, when you test your code, you give the input what it takes and you give the expected output. Okay, so the framework will run your code, right, will execute your program, and it will pass the input that you have specified, and whatever the actual output it gets, it compares with the expected output. If it does not match, it will mark the test case as failed. Is it clear to everybody? I'm sure for some of you, it's all recapping what you know, but still, just for the benefit of the larger audience, I explained what is JUnit. No response at all. Friends, are you still in the festival mood? Okay. Okay, it's the same way. See, some of the fundamentals are required here. You should remember these words: input, actual output, expected output. Okay. So this MR unit, it provides us a framework to test our MapReduce programs, right? So how does what are the features it provides? Okay. It provides us some drivers. Okay, sorry friends, some background noise. I mean, I don't have any control. These people have suddenly appeared from nowhere. Okay, is that okay? They'll be gone in few seconds. Okay, so let me know if it gets worse. I'll stop for a few minutes. Okay, If it gets worse, do let me know. I will stop. Okay. Coming to this MR unit. Okay. So MR unit framework, it provides us some library. You can see this is Mockito. You can see this. Okay. This one. See MR unit Hadoop jar. MR unit Hadoop jar. So this is the one which has the libraries, right? Which has the APIs that we will be using in our MR unit program. Okay, it has some dependencies. It uses Mockito and Hamcrest and JUnit. Okay, you need all these 4 jars: Hamcrest, JUnit, Mockito, and MR unit. Okay. Here you can see it provides, MR unit provides drivers. One is the MapReduce driver, okay, to test our MapReduce program, and map driver to test our mapper program, and reduce driver to test our reduce program. Okay, reducer program. You can see this MapReduce driver. The input is, okay, there are some parameters here. The parameters are mapper input key, mapper input value, mapper output key, mapper output value, reducer output key, and reducer output value. And this is used for testing our MapReduce program. And this driver, map driver, this has the data types: mapper input key, mapper input value, mapper output key, and mapper output value. This is to test our mapper program. And this is the reduce driver. Okay, this is to test our reducer program. Okay, and this is the reducer input key, reducer input value, reducer output key, and reducer output value. Okay, now we will understand how we can use these drivers to test our MapReduce program. Okay, so there is a method called setup. Okay, so there is a method called setup. So what this setup will do is it will initialize these drivers. Okay, in the setup method we initialize the driver. You can see here the map driver. So we are initializing by calling map driver dot new map driver. Okay, to this we are passing our word count mapper. Okay, this word count mapper, what it does, it takes a line, it reads a line, converts that line into an array. Okay, you can see here it reads a line. Okay, and basically this is a string tokenizer API to convert it into tokens, and then for each token it is emitting the word and the numerical one. Okay, this is our mapper code. And then we have a reducer which does the just aggregation. It iterates over the values and it just counts the number of occurrence. Okay, you can see what it does. It just iterates over the value and it just aggregates it. And you have the MapReduce driver. So we set the driver by calling MapReduce driver dot new MapReduce driver. Okay, here we are setting the mapper and reducer. This MapReduce driver is used to test our MapReduce program. So we set our mapper and we set our reducer. There are some annotations used. Okay, there are some annotations used. You can see some annotations. These are all the JUnit annotation: at before, at test, at after, right? So these are all annotations. So what is the meaning of these annotations? So this at before annotation is a JUnit annotation. This gets called before the execution of the test methods. Any method with the annotation, right, at test. So this is a JUnit test method. So when we execute this program as a JUnit test case, this method gets called. This test gets called. Okay. You can also see that there is a before method. So what this before method will do? Okay, when before the execution of before these test methods are called, this okay, at the method having this annotation gets called. Okay, this method gets called before the execution of test method. Okay. all MR unit test cases, the MR unit is built on top of JUnit. MR unit is built on top of JUnit. So all MR unit test case, they extend test case. Test case is a, okay, it's an API inside JUnit framework. Now you can see that inside your test case, right? You can run multiple tests. So what I have some tests only for our mapper and reducer and map reduce driver. When you write, you can run any number of tests at all. Tests. Okay, all you need to do is just annotate with that test method. Now let's see what we do with the test. How do we test our map function? Okay. So the map. So we test our map method by using the map driver, and we specify what did we decide? We will specify the input, right? And we specify the input, and we specify the expected output. Okay. So we have already registered our process. That's a map process. Well, now we need to specify our input and expected output. Okay. So now you can see this. We are specifying that here. Map driver with input. So this is the input that we are specifying. Okay, input is this. Okay, input of our map is okay. The byte offset, some byte offset, and okay, and this is the line. So what should be the mapper output? What should be the mapper output, friends, for this input? It should be apple 1, grapes 1, right, and orange 1. Correct. So this is the expected output. Let's see what we have put. So you can see with input, this is the input that we are passing. With output, we need to specify the expected output. So here you can see apple 1 with output orange 1 with output grapes 1. For this input, this is the output we are expecting, and then we call the run test method. Okay, run test method. Now if there is any failure of the test case, for example, if the expected output does not match with the actual output, what it will do? It will call this assert.fail method. Okay. Now similarly, how do we test the reducer? For the reducer, okay, it takes key and list of values. For the reducer, okay, Amarnath, I will answer your question, Amarnath. Okay, after completing this, I will answer your question. How do we test the reducer? For the reducer, the input is key and list of values. So our key is apple, list of values is 1 and 1. Okay, let's see. Key is apple, list of values is 1 and 1. So what will be the reducer output, friends? Here, what is the output? Expected output. No, for this input, no, this we are testing a reducer method here. This is a different method altogether. This is the input for our reducer. See, for this method, I want everybody to answer this, right? We can individually test our mapper and reducer. We are now testing our reducer. To test our reducer, I am passing this as a key and this as the value 1 and 1. Right? This is what I am setting. Values dot add 1. Values dot add 1. This is a list. I am preparing a list, right? And then I am saying this is the input. Apple is the key and value contains 1 and 1. So what is the expected output for this? It's 2, right? So this is the apple and 2. And similarly, we can test our entire MapReduce program also. To test the MapReduce program, we use the MapReduce driver. Okay. For the MapReduce driver, this is the input you are passing. 1, okay, apple orange and apple orange. So what should be the output of our program? The output should be apple to orange 2. Okay, this is the output, expected output. That's what we specified. Apple to orange 2. Now let's execute this. To execute this, it is very simple. Right click and run as JUnit test. You can see the J rate, all the tests passed. Mapper successful, test reducer successful, test the mapper job successful. Now let's run some technical tests. Let's say that for this line, apple, orange, grapes, let's make grapes as 2. Okay. Now our input is not matching the expected, our input, right? This is the expected output we have provided. Let's run and see if this expected output will match with the actual output. You can see that there is an error. Okay, you can see this, our mapper function failed. So this is the console. If you go to the console, okay, you can see what it says, missing the expected output. So this is what we said, expected, grapes 2. But what we received, unexpected output, grapes 1. So is it not a good feature to test our MapReduce program, friends? Yes or no? Okay, so we don't have to build a jar and okay, we don't have to build the jar and run it on okay, cluster. Okay. Now our friend Vivek says, can we give input dynamically here? Dynamically, so command line. No, you cannot do that, Vivek. Okay, so you can, what you can do is, but you can. No, that is how you have to. No, you have to specify. That's how you write the test case. You define the input beforehand. Okay, all you want. If you want to do with the different methods, you can write multiple methods. If you have multiple inputs. And our friend, one of our friends says, which is Amarnath, right? Let me just see. Okay. Amarnath says, this is fine for small data. What if we have large data? Are you talking about number of rows when you say large data, Amarnath? If you have billions of rows? See, Amarnath, it does not really matter, right? Suppose, let's assume we are so our friend says, let's have billions of rows. Billions of rows. Suppose if you assume that we are doing a very simple word count, right? Does it really matter does it really matter? Because does it really matter the volume of data here, friends, for MR unit? The volume does it really matter? Because your map function works on a single row, right? So all these gets executed parallelly. So the volume of data does not matter at all, Amarnath, because whatever the function that works for the single row, right, single key value pair, it will be same for all the mappers, so it will not change at all. Is that clear? Whatever the operations that works on a single key value pair, it will be same for the billions of key value pair. It will not change at all. So volume does not matter. Urvi says, just to confirm, just we need to include the dependent jars, not requiring Hadoop cluster environment. That is correct, Urvi. You don't need Hadoop cluster. You just add the dependent jars. I showed you the dependent jars. Right? There are 4 jars here. Right? Okay. Hamcrest, JUnit, Mockito, MRUnit. MRUnit is the one because MRUnit just uses all these dependencies. Okay. And you need Hadoop core also because you have MapReduce, so you need Hadoop core jar as well. Now let's move on. Now let's talk about counters. Let's talk about counters. Counters are basically used to track the progress of the job. for example, what will happen sometimes when you process billions of rows, right, using the MapReduce programming model, when you process them parallelly, sometimes you will come across a lot of bad records, right? So in those scenarios, you would like to keep track of the number of bad records that you encountered. The easiest way to track them is by using counters. Okay. Counters provide you a mechanism to update, right? To update some counters from your mapper program and reducer program, and that counter will be available on the job tracker UI. Now we will see how to do that. Okay. Let me take an example here, a case study. Here you can see. So here you can see this data. Assume that we have some records, right? These records have timestamp, and we want to know how many records we received for the different months, right? How many records we received for January, how many records we have received for February. Okay. If you have some use case like that, so what we need to do, we need to just parse the timestamp, extract the month, and update the counter. Okay. And this counter will appear on the job tracker UI. You can see here some explanation. While developing a Hadoop application, we will be interested in gathering information about the data we are analyzing, like how many types of records we processed, how many invalid records were found. Okay. And this, if you want to do this, then you can use counters. The counters, now let's try to implement counters for this. We have an input data set like this, right? Let's try to track the number of records for different months that we have received. So I've written counters in using both old and the new API. You saw this, right? The old and the new API. Okay, this is the old API and this is the new API. Okay, using the old API, you use the reporter. Okay, we use the reporter API to track the counters. In the new, you use the context. Okay, in the class, I'll demonstrate how to use the new. I have example. You can take a look at how you can use the old API to do that. Let's look at our driver. So our driver class, we are using the new API. We are creating an instance of job, registering our driver, setting the job name, okay, setting the number of mappers reduced as 0, okay, and we are setting the mapper class here. Okay, let's look at what is the mapper does. In the mapper, it is getting a key and value, right? And the value, we are using the text input format, so the value will contain the record, which has the record ID and the timestamp. So what we are doing, we are splitting it into array, and then we are extracting the timestamp, and using the timestamp, now we are finding out which month it belongs to. Okay, you can see time.getMonth will give us the month number. This index will be from 0 to 11, 0 for January, 11 for December. You can see there is some logic we have put. This just to show you the how to maintain counters. If the month is December, we are using the context to update the counter. Context dot get counter. Get counter is the method we use to get the counter, and the increment is the method you use to increment the counter. Okay, and get counter, and this is the counter name, month dot December. So this is an enum that we have declared. Okay, enum is a feature provided by Java to define some constants. Okay, public static enum month. So it has 3 constants: December, Jan, and Feb. Now we can see month dot December. Okay. So this is one enum. If the month is December, we are incrementing the count by 10. Okay. And if it is Jan, if we are using again the get counter method and the increment method to get the counter and increment the counter. And similarly, we are doing it for Feb also. And this is how this is important. Get counter context.getCounter.increment get counter and the increment method. So they are important. How to fetch the counter and how to increment the counter inside the map. So you can do this inside the reduce as well. Okay. Now coming to this, you can see this. We are calling the job.waitForCompletion method to execute the job on the cluster. So once it completes, the control will come here. So now job.getCounters will return us all the counters. Okay. Now once you have the counters, you can use the find counter method and pass the counter name to fetch. Okay. To fetch the counter. Okay. You can see find counter. You pass the counter name and you are fetching the counter, and then you can use the display name and the get value method to get the name and the value. Okay. You can see c1.get display name, c1.get value. This is the method you can use to fetch it. Now, if you are tracking bad records, right? If there are, let's say, you can define some threshold. If every day, if a bad record is more than 1 million, you want to alert your support team. So you can put that in your driver class. You can add a piece of code. Right? If the number of bad records count, if it is greater than 1 million, send an email to operations team. Okay. And that piece of code you can add here. You can call some SMTP server and send an email. Okay. So this is a use of the counters. Okay. So shall we see the execution, friends? Now let me create data. Let me add the data for our counters example. So created a directory. Now let me add the data. So we have added the data. Now let me execute the program. Ashutosh says using counters we can get the data for help us to get the data for debugging purpose. Monitoring purpose I would call. Yeah, debugging you need, yes, I mean it will give you a high level information, how many failed, but it will not really give you it will give you only the count. Okay, it's a lightweight. It's a lightweight, Ashutosh. You cannot store the exceptions, but you can track the counts. Okay, so this is so let's execute our counter program and see the output. Okay, we should be able to see the counters on the UI as well as in the job summary. You can see here, this is Argon counter. Okay, you can see there are some records for December and there are some records for January. Okay, it is appearing in the job summary, and you can see that on the console as well. On the here job okay, counters test. You can see here when the job is executing, you can see these counters, how the job is progressing, how many bad records we have received so far. Okay, all that will be updated here. Is that clear, Ashutosh? I mean, it gives you can use this counter information inside your driver program, and you can do some appropriate. You can make decisions, and you can send emails, or you can update some status. Okay. Of your ETL jobs. So various things you can do. Raji says where we have to use job and where we have to use configuration. Okay. So job internally it creates a default configuration, Raji. Okay. even though we created a job, right, new job, it internally creates a configuration. So configuration is something that you use. You can see here when we execute, right, here it asks, it says generic options parser. Okay, so this generic options parser, okay, you can explore about this. So this, if you use, right, you can automatically update the configuration. In the sense, okay, like some of the job configurations, like your job tracker address, name node address, okay, various other things and some other parameters. So you can take it from the command line, okay, and you can use the generic option parser and you can update the configuration object and you can pass it to job configuration. Okay, so you use it along with the generic options parser, Ashutosh. Sorry, it was Raji. Is it clear, Raji? Okay, you can explore about it. You can take it as an assignment. Okay, you can use the configuration along with generic option parser. You'll find loads of examples on the net. Basically, you can see this generic options parser. Meaning of that, you put it in the command line. This is my name node. This is a job tracker, right? Use compression, various other some of the configuration parameters. You can set it in the command line itself. So if you use that, then you can use a generic option to parser to parse it. And if you pass a configuration object, it will automatically update. You don't have to do like, you know, set configuration dot set job tracker, you know, argument of 5. Okay, you don't have to do all that. This is the why, you know, they have split into job and configuration. Okay, you can read about it. Next, let's move on. Oh my God, man. Hey guys, am I slow? Was I slow? Radhakant Ashutosh says no. I feel the rest of the class. Does it mean yes? Okay. Now let's take a look at the distributed cache, friends. Okay. Let's take a look at distributed cache. So distributed cache. Now let's go back to, okay, let's go back to our techniques, right? Map side join technique and ready side join technique. In the map side join technique, what did we say? We said that the smaller data is loaded into memory using the distributed cache feature, right? Now let's understand what is this distributed cache. What does it do? Jyoti says I'm from non-Java. No problem, Jyoti. That is the reason why, you know, I'm writing the pseudocode on the blackboard. I know it is taking my time, but in spite of that, I am doing that. Okay, I know that there are people from non-Java background. That's the reason why I'm not directly, you know, jumping onto the onto the code. Okay, is that okay, Jyoti? Are you getting the concepts? Okay, great. Now let's talk about distributed cache. Distributed cache, friends, you can use this to make some resources available for the mappers, for your mapper task. Okay, if you need some resources, assume a resource can be like you need some configuration file, some file for your mapper task to run. Okay, or if you want some Java archive file for your mapper, or you want some text file for your mapper task. Okay, so all that, I mean, if you want to make some resources available for your mapper task, what you can do is you can use the distributed cache feature. So what does distributed cache feature will do? Whatever the file that you specify as a cache file, assume that, you know, this is HDFS, right? Assume this is HDFS, and we have created one file here in HDFS, and this we have mentioned it as a distributed cache, okay, in our MapReduce program. So what it will do, the framework, assume that these are the nodes on which your map task runs. Okay, so what framework will do, it will copy this small file, right? Sorry, So it will copy this small file, to this node, to this node, to this node, and to this node. Okay. It will copy to a folder on the nodes where your map task runs. This is the distributed cache feature that Hadoop has provided. So it will basically copy that file from HDFS onto the local node itself. If I have 10 mapper task or 100 mapper task, let's take a 100 mapper task. How many copies of this will be, okay? How many copies of that will be there in the cluster? 100, right? It will copy the 100 nodes. Okay, you can see here these files are copied only once per job. Okay, it can you can even archive it whenever you specify some file as a cache. You can archive it. Okay, so this internally it will unarchive it. Basically, it will unzip it. Archive means you compress it. It will do the uncompression. Cache, it can be multiple files. It can be a text. It can be a jar, right? Various other files. Radhakan says, does it depend on the number of nodes or number of mappers? Okay, it basically depends on the number of mappers. Okay, wherever your mapper runs, wherever your mapper node runs, right? Wherever your mapper runs, it will copy to that node. Now let's understand. Let's take a simple example and understand the features. So it is very easy. Just only one. Okay, it's just one method that the framework provides us to make some file as a distributed cache. So here, what do we have? Okay, let's take a use case. We have, let's say we have input data like this, which has a state code UP, Maharashtra, West Bengal, Bihar, right? It has only the state codes, and this is state population. Okay. Assume that we are asked to replace this or add the state description as well to these records, right? Assume if it is too large, we have billions of rows like this. How do we do that? Okay, how do we do that? So basically, this is an example for map site join technique, where we have one file, we have one data set which is very small, another data set which is very large. The smaller data set is the mapping between the state code and the state description. Okay, this data set we can load it into memory. Okay, so how do we load it into memory? We make use of the distributed cache feature, and we'll ask the framework to copy that file to each of the node where the mapper task runs. Okay. Before after that is copied within the mapper task, we will write a piece of code to load the data from the disk, from the local disk into memory, okay, into a hash map or a hash table, and then use it inside our map function. So what is the output expected? I'll show you the output expected. So what is the output expected from here? Okay. The output expected is state code, state name, and population. Now let's run this. Okay, first let's load this data and then we'll look at the code. First load this data. This is the data. This is the cache data. Basically, it will contain this is the folder to store our state code and state description mapping, and this is the folder to store the larger data set. That is the population and the state code. Now let's load the data for the state code and state description mapping. We have added, and let's load the data for Okay, so what did we create? We created distributed cache demo, right? So this is the one we should be using it. So let's look at it. User Cloudera class 4 input data. Okay, you can see this. This is our larger data set. Okay. Now let's look at the code. How do we write the code to get the required report? So this is how it looks like. Can you please scroll to the left? Vivek, where Vivek in my editor? Are you asking in my editor? Where are you asking me to scroll, Vivek? We don't see your screen properly. Is that the problem with others also? Eclipse. Vivek, you need to set your zoom properly, Vivek. Set the zoom to 100%. Can anybody help Mr. Vivek, please? Urvi, Abhijit, how are you guys? Are you guys facing this problem? Anand, Ashok, Ashutosh, Chandan? Are you guys able to see my Eclipse properly? I don't have your view, Vivek, you need to change your zoom appropriately. Make it 100%. I think on the left hand side corner you have zoom settings on the webinar window. Okay, great. Vivek has done it, so let's resume. So this is, let's go to our driver class. This is a distributed cache. So what are we doing? Here you can see we're creating an instance of job, and then we are registering our driver class, and we are setting our job name. Okay, job name is some name, distributed cache test, and we don't need a reducer here, so we are setting it to 0. And this piece of code is important. Okay, so this is a piece of code which tells the framework that this data, this file should be copied onto the node on which the mapper task runs. Okay. What is the API name? Distributed cache dot add cache file. Okay, and this is the HDFS location, and this is a configuration object that you would pass. Okay, and okay, here if it is an archive file, there is another method. You can see add archive to class path, add cache archive. You can see if it is an archive file, you can use add cache archive. I mean, if it's a cache file, if it's a text file, you can use the cache file method. So this is one line, but that tells the framework to copy the file onto the node where mapper task runs. Now let's see what do we do in the mapper. You can see set mapper class. So what do we do in the mapper with that file? We need to load it to memory, yes or no? Do we need to load the smaller file into memory, yes or no, friends? for the distributed for the map side join? Yes, we need to load it to memory. How do we do that? It is done inside the setup method. Setup is called once for the mapper task. Okay, it will be not called for each line it reads. It will be called once for the mapper task. Okay, mapper task processes one split, right? It gets line by line from the record header and processes that. So this setup method is called for once. So here you can see setup method. Here it takes the context, and this is the method distributed.cache.get local file, load local cache files. It will return us the list of files. Okay. So once we get the list of files, what we do, we iterate over them and look for the file that we are looking for. So our file is abc.bat. This is the one which contains our state code and the state description. Let me show you. Okay, where it sees it, it is in distributed cache. Okay, so distributed cache demo. Okay, it is in MapRed cache. It is in MapRed cache. User Cloudera MapRed cache. This is abc.dat. Okay. This is the file which has state code and state description. So this is abc.dat. So what we are doing, then we are loading that into memory, right? What is the collection API we are using? Collection. So you can see we are using AB map. Okay, this is a hash map. Okay. AB map which contains the mapping between the state code and the state description. For that we are using a hash map. So hash map. So what we are doing? We are splitting the inside for each line. What are we doing? We are splitting into tokens, and we are reading the state code and the state description. This is the state code and the state description, and we are storing that into hash map. Okay, the people from Java, they will know that hash map is one of the collections API provided by Java, using which we can store key value pairs. Okay, in the hash map, when we key value pairs are stored using put method. In order to fetch, we use the get method and we pass the key name. So this is the setup method, and then we will look at the map method. Map, what we do for each, so it's taking key value as input. Okay, for each value it reads, we are converting into tokens, and token as the tokens, right? For each line it has the state code and the population. We are taking the state code and we are doing a lookup ab.abmap.get. It does a lookup in the hash map and it is getting the state description. Once we get the state description, what are we doing? We are outputting. You can see the output key dot set. We are setting the state name, and output value is the entire row that we have received. Now it has this. This will the output look like. It will have state description, state code, and total population. See, the idea here is to understand how to use distributed cache feature. So shall we go to the execution part? You can take a look at it. When you are ready, let me know. I will go to the execution part, friends. Shall we see the execution, friends? Abhijit, Anand, Ashutosh. Okay, let's see the execution. You can see this, it has now let's verify the output. The output is in we have the output in class 4 output, distributed caching output. So this is the output. Radhakant says, is set up a lifecycle method? Correct, Radhakant. That's a lifecycle method. It is called once for a mapper task, Radhakant. So each split is assigned to your map task, and for each split it will be called once. Now we saw the distributed cache feature also. Now we'll move on. So there is one topic left. I need 10 more minutes. Is that okay? Can I extend it? So tomorrow we can get started with PIC, friends. I need just another 10 minutes. We will talk about sequence files. Is that okay? Tomorrow let's get started with PIC. Let's not mix Java with PIC tomorrow. Is that okay with everybody? So what are sequence files? Right, I was talking about it a lot of times, right, earlier. So sequence files, right, this is a file-based data structure provided by Hadoop to deal with binary data. Okay, all of you know about the binary data, right? Have you seen binary data? Vivek says yes. Yes, binary when everything in fact is binary only, right? Everything, whatever, anything we see, everything that we see here, it's all binary. Whatever there is a representation, this is just some interpreter is reading that, right? It understands what it contains. So internally on the disk, everything is stored as the ones and zeros. So let me open this. This is an example for binary data. You can see this, all some characters not recognized by the editor. Okay. So your byte, right, it has 8 bits, so you can turn on zeros and ones, you can play with that, but there are some range of values. Basically it is from 67, correct me, it is maybe 65, ASCII they call it as, you know the ASCII range, those 100 odd characters, only those characters your editor can recognize. Okay. Vivek says he cannot hear me. Have you heard of ASCII, friends? ASCII characters, right? ASCII are the ones that your editor can recognize, right? So the ones which do not, right, and the ones so these are basically ASCII are the ones, these are all human readable. This is what we call it as text, right? These are all the human readable characters. Anything other than any values other than this ASCII, they are all called as a binary. It's all 0 and 1s. Only the specialized, the software. Sorry, 1 second. Sorry friends. Here, so right, anything other than the ASCII, right? We need a specialized software, right? Like an image editor can read an image. Here, this one, right? So it can read it. So it is displaying because it has a coder decoder. It knows what it is. So this kind of data is called as binary data. When you want to deal with the binary data, then Hadoop provides a sequence file. Okay. Hadoop provides a sequence file format. Okay. Sequence file format. It's a file-based data structure. So what it has placeholders for keys and values. Okay, let me explain that. So understanding key value pairs is very important. This sequence file is really important because this diagram will help you to. Okay. So you can think of like a friends here. Let me put it like a. Okay. You can think of it as a like a table, right, which has placeholders for keys and values, right? Here you can see this is the key, right? So this is the key, place for key, and this is the place for value. So it's a file-based data structure, right, which has placeholders to store binary keys and binary values. Okay, so this is the binary data and this is also the binary data. Now the advantage of using the sequence file formats is, okay, the advantage of using the sequence file is you can compress the data whatever you store here, right? Whatever the value you have, it can be in any can be of any size. So if you have this data, you can compress it. You can compress the sequence file. So let me show you that. Okay, let me show you what kind of compression it supports. Here you can see it's a binary. What is it? It is a sequence file. It consists of a binary key value pair. It is used in MapReduce input output format. Your input output format you can store in a sequence file. Okay. And optionally you can turn on you can ask the framework to store your mapper output in a sequence file format. Okay, you can use that as well. Okay. The sequence file, it provides a reader and writer to work with the sequence files, and there are three different types of sequence file formats. Okay, one is uncompressed key value records. This is one. Like if you do not compress, if you leave the key value, this is uncompressed file formats. Or you can go for the record compressed key value. That means you can compress the value. Okay, you can compress only the value. You can compress only the value, and then there is a block compressed key value records. Okay. So blocks means your collection of key values are compressed. So this is the block level compression. You have a record level compression, and there is uncompressed. So these are the three different types of sequence file formats. Oh, you can see the record, right? Your sequence file, it appears like this. Though it is internally, it's a file-based data structure, it has some headers as well. Okay. So it has some header. You can see this is the header. It will have the data type okay, and other information. And then you have a record. This is what is a record, right? And you can have a collection of records, and then you have a sync. Okay, sync is a marker interface. Okay, this says, okay, this is the end of one block, and this is the beginning of second block. Okay, this indicates the block. This is sync. Sync is a marker interface, and within the record you can see it has some information like, okay, record length, key length, and then you have the key and value. And here is an example for record compression. So when you have a compressed record, ignore this. It's not block compressed. When you have a record compression, what happens? What is compressed in a record compression? We talked about three types, right? One is the block compression, the record compression, and uncompressed key value. So which is compressed in a record compression, value or key? So value is compressed. You can see this, value is compressed. Okay. And similarly, you can go for a block compression, wherein your block is compressed. Okay, it has like this has the details. It has these details like number of records, compressed key lengths, compressed keys, compressed value lengths and then the compressed values. So this is an example of the sequence file. This is the block compressed sequence file. Okay. Now demo of sequence file. So let's do this. What I have is I have these image files, right? So these image files, let's put them into HDFS and create a sequence file and store it in a sequence file. Okay, let's see how it can be done. For that, first let's first load the data called images. For that, let's load the data images into HDFS. So this is an images folder that I'm creating in HDFS, and I'm load all the images. Okay. So I loaded all the images. Let's browse them. You can see. Okay, we have not loaded the data yet. Okay, this is just we created another image list folder. So let's load the data. This is a command for loading the data. This is fsput, Hadoop fsput images into images folder. So let's load the data. Now it is loaded. So let's go to HDFS and see. You can see this. These are the images. Now let's add one more file which has all the locations of these images. Right? This I will show you. Once we add it to HDFS, I will open the file and show it to you. So this file, whatever we added just now, it has the locations. So it is in Cloud class 4 input sequence file demo. Sequence file demo. Now you can see this. This is the location. These are the HDFS location in which we have added those files. Now what we want to use the sequence. What is that we want to do? So we want to store those binary data, okay, in a sequence file format. Now let's see how we can do that. So this is our driver class, binary files to Hadoop sequence file. Okay. Let's go to the main method. In the main method, so this is a job object. Okay. We are giving the name here, and we are registering our driver class. Okay, and this is our mapper class. Okay, and this is output. Okay, this is the output value. You can see byte rateable. The output key is a text file name, and input format, text input format, but the output format is a sequence file output format. The input to our MapReduce program is the list of the images, not the images as such. We'll provide only the list of images as an input, and what our mapper program will do, it will connect to HDFS and read the data from HDFS. Okay, and output format, you can see it's a sequence file output format. So it will store in a sequence file as a key value pair. Now let's see that. Let's look at our mapper class. So this is our mapper class, right? It's getting the key and value. Right? Value is the location address, the address of the image in HDFS. You can see here. This is the value, right? This is the HDFS address, and what we are doing, we are using the file system API. File system. You remember, this is a FS client, file system client. This is a Java. This is the client that we use to connect to HDFS in order to read the data from HDFS. So FS, you can see, it's part of the package Arg Apache Hadoop FS. So using this, what we are doing, you can see this, we are creating an instance of FS input stream, data input stream. We are opening the stream to the image that we have in HDFS, and we are creating a byte array output stream, and and then we are reading from it from the HDFS, and we are reading it in a byte array output stream. So once everything is done, so what are we doing? We are converting this byte array output stream, right, into bytes writable. You can see it is converted into bytes writable using the byte array output stream, which is converted internally to byte array. So once we have this the bytes data, so we have this context dot write. It is writing the value. Okay, here the value is the file name, and then this is the image binary data, and finally we are closing the streams. So here you can see this is the value, this is the file name including the HDFS location, and this is the binary data. So since we use the sequence file output format, it will write the data into sequence file. Okay. So let's see the execution and you will understand what it does. So this will be the input for our mapper program. Okay, internally our MapReduce program, internally it reads the data from HDFS. Now let's look at this. Now run the program, Hadoop jar, right? For the jar we give the jar name, driver name, then the location, image list location, and the output location. Let's run this. You can see that and it has completed. Now let's look at the data. That's what we are interested in, right? You are all curious to know how the sequence file looks like. Okay, so we'll be seeing that shortly. This is our Cloudera class 4. Sequence file output. You can see it has created only single file. This file size is 11 megabytes. Okay, you can enable, if you enable compression, there are options, you can reduce it. So here the file size, it has created single file from all those small tiny files. Okay, if you open up, then you will see the sequence file, which will have some header, right? You can see it is some sequence, right? And then in the header, it has the data type of the key text, and this is the data type of the value. And then you can see this is the location. This is the key location, right? The key containing the file name. Here you can see autoloan.png, and then this is the value, the binary data. This is what you can do with the sequence file. Any questions, friends? Sequence file? Abhijit, Amar, Ashutosh, Chandan, Nishit, Radhakant, Raji, Urvi, Vivek. Can you get a smiley, friends? Where exactly is the sequence file used? Okay, good question, Amarnath. I was expecting this question. Okay, so sequence file, I mean, if you have too many files, okay, those are good questions. So I was expecting these questions. Okay, way to use of sequence files, right? I mean, if you have too many small files, one way is if you have too many small files, right? I mean, you can easily merge them. Okay. Too many small files, you can put them in a sequence file. Okay, this is one use case, and then you can use it when you want to deal with the binary data. And then another use case is, I mean, if your data size, if your text data, right, as such, if it uncompressed, if it is too large, then you can go for a sequence file because it gives us enormous compression. Always we know this, binary data is more compressed, offers more compression, right? So these are the uses of a sequence file. Okay. So whenever your data is too large, you don't really keep it in a text format. Okay. Is that clear, Urvi? Amarnath? Okay. Do we need a mapper for this example? Do we need mapper? Yes, we need mapper. In this example, we have used mapper. Mapper is the one which does it, right? Which read the locations and which read the data from HDFS. Okay. Now what you can do further, right? You can use an assignment for you guys. Use sequence file input format and try to find the duplicate images in the sequence, the output file generated. In the output sequence file, okay, right, use the sequence file input format, write a new MapReduce program, find the duplicate images. Can you do that? Now you will know how to work with the duplicate binary data as well. Can you take it as an assignment and do it, friends? Okay, too many assignments, isn't it? Okay. So with this, we are ending our discussion on advanced MapReduce feature, friends. So these are the, okay, if you want to look at, if you have some time, you can take a look at PIC. Okay. Some installation documents are here in LMS, you can read about them. Basically in Edureka website, there are some blogs, you can read about them. So all these examples that we have discussed now, I will upload it to Google Drive in maybe next 10-15 minutes. In next 10-15 minutes, everything that we have discussed in the class, I will upload, including the Blackboard discussion board. I'll just take a break for 5 minutes and have some breakfast, and then I'll do this. Are we good? Jyoti, Abhijit, Amar, Anand, Ashutosh. Are you guys okay? Any questions? Do you guys feel overwhelmed? What is predominantly used in Hadoop framework? Amarnath says, what is predominantly used in Hadoop framework? Hadoop has two components, Amarnath. One is the storage and the processing. Some people use it for storage also. When you throw the commodity hardware to the framework, right? You can store any amount of data that you want, and people use it for data processing as well. See, all we do is, have you heard of descriptive analytics and predictive analytics, Amarnath? Are you from data analytics background? Do you know about descriptive analytics? Okay, so Hadoop is mostly used for descriptive analytics. I mean, even for the data preparation for predictive analytics, and mostly for descriptive analytics. Okay, wherein you take the data from multiple processes, right? Clean up the data, process the data, and generate the aggregated data. So this is what is part of your descriptive analytics. In predictive analytics, what you do, you prepare the data for your, for your data scientist to come up with a model. So does that answer your question, Amarnath? Okay. Yeah, you guys need to read about this. You guys should be familiar with all these words, friends. So since you all love data, you should know about this. Okay? Vivek says, can you explain what is job config in distributed cache? Oh, job config, that's just a configuration that it takes use internally. It uses Vivek, right? Your configuration will know where is the name node, where is the data node. Let me show you that here. Are you talking about this? Distributed cache.add cache file, job config? Here. Okay, so this configuration is the one by default, right? It will have the details of, okay, so where is your job tracker, where is your name node, and other details. If your cluster information will be there in the configuration stuff. Is that clear, Vivek? You can read about it on the Apache documentation also. You will find a lot of information. Okay. So with this, we are ending today's discussion, friends. Thank you very much for joining today's sessions. Okay, I hope you learned a new thing today. I look forward to see you guys in the tomorrow's class. Okay, and please do fill up the survey form. Okay, please do fill up the survey form. It's a request from to you. This is one of the quick assignment for you is fill up the survey form. Yeah, so it's easy. Thanks. Take care. Have fun.